Alright, what we're going to go through in this is the one-step conversion. When you're doing any kind of conversions, you have to remember you need to know where you're going and where you're starting. So you need to know what you know. In this case, we are going to kilograms. So we write down kg, because that's the abbreviation for kilograms, and we write down our railroad tracks. Remember, that's so we can keep track and look back to see where we're going. The next thing we need to do is write down what we know. That's what they're giving us in the problem. In this case, they're giving us 2.3 grams. When you do this, remember, what's on top always falls down. So if I have grams on top, grams go on the bottom. And if I'm at a base unit, a gram, a meter, or a liter, that means I'm at home. And if I'm at home, I can go anywhere I want. In this case, I look back where I wanted to go is kilograms. One always goes with the prefix. In this case, that kilo is the prefix. So I put a 1 with the kilogram. From your conversion table, 1 kilogram is 10 to the third grams. I have gram on top, I have gram on the bottom, so they cancel out, leaving me in kilograms, which is where I really wanted to go. Multiply across the top. So if you take 2.3 times 1, you have 2.3. Multiply across the bottom. There's nothing here, so now I have 10 to the third. Take your 2.3 divided by your 10 to the third in your calculator, and you get 2.3 times 10 to the negative third. That's if it's in scientific notation. If it's not in scientific notation, in your calculator, it might look like 0.0023. Remember, a number without a label is no good. In this case, what was our label? It was that kilogram. All numbers need to have a label. That's one example of a one-step conversion. Another example of a one-step conversion, we might have a little bit different setup. In this case, we are going to the base unit, which is grams. So I put down grams and I put my railroad tracks. In this case, what I know is that I have 590 milligrams. What's on top has to come down. So the milligrams comes here. If I have something that has a prefix, that means I always have to go to the base unit. Remember that base unit is always going to be that second part in there. So my base in this case is grams. Now, since this one has a prefix, anytime they have a prefix, that means it gets the number 1. A milligram is 10 to the negative third grams. I have a milligram here, I have a milligram here, one on the top, one on the bottom, they cancel out, and I'm in grams, which is where I wanted to be to begin with. I multiply across the top, so if I take 590 and I take it times 10 to the negative third in your calculator, you're going to get 0.590. Divided by the bottom, which is only 1, so therefore you have 0.590. Remember, a number without a label is not good enough. You look back to where we were going, our label needs to be in grams. All numbers have to have a label. Now, one last situation that we sometimes run into is that we have a number that's already in scientific notation, but we're still going to set it up the same basic way. Where am I going? I am going grams. What do I know? I have 5.6 times 10 to the 5th decigrams. What's on top has to come down. This has a prefix, therefore this needs to be the base unit. 1 always goes with the prefix, and 1 decigram is 10 to the negative 1 gram. I have a decigram on top, I have a decigram on the bottom, so they cancel out and I'm in grams. Multiply across the top, so you're going to take your 5.6 times 10 to the 5th. The biggest thing you have to remember is when you put this in the calculator, make sure you put that in parentheses before you take it times your 10 to the negative 1. When you do that, you're going to get 5.6 times 10 to the 4th, and don't forget that label of grams.